So what we've got pictured here is a graph that represents the velocity of the car as a function of time. The car stops at the 4-second mark, but I'm observing it till the 9-second mark. I would like you to tell me how fast it's going at 9 seconds. And I would like you to tell me how far did it move forwards and how far did it move backwards. But we are observing 9 seconds of the car's motion. Let's say, for example, that you guys are, say, not as advanced in math as I like to think you are. In the first second, how much did the object's velocity change? 2, right? If I just look at the graph and we're careful about it, it increased, became more positive by 2 meters per second. If you don't like that argument, you could, of course, make the argument that there is a slope that could be calculated because this is a linear function. And based on I'm not even using any physics here, I'm using Algebra 1 skills. Using Algebra 1 skills, I know of a function that can tell me about how a line will behave. In that function, I could find the slope by doing rise over run and picking 2 points. 2 points I could pick would be 8 and 0 and 0 and 4. Do you guys see those 2 points? If I find the slope, the change in y is positive 8, and the change in x is positive 4. That is a slope of 2. If I finish this off, I'd put the y-intercept, which is negative 8, where b is. We did this exact thing yesterday when I explained a mistake I made. Now, if I want to know how fast it's going at 9 seconds, all I must do is put 9 in for x. When I do so, I will find that the velocity there is 10 meters per second. Right, well within Algebra 1. I should be able to count on this skill. I then said to go one step further and tell me how far the car goes backwards and how far the car goes forwards. Well, the area here is how far the car goes backwards. It's triangle, right? Not even a complicated trapezoid, just a poor old triangle. 1/2 base times height. The base is 4, the height is negative 8. Seems to me like 1/2 times 4 times negative 8 is going to give me negative 16 meters. The car went backwards or in the negative direction 16 meters. In the next time interval, the car travels in the positive direction. This area is positive, it is above the axis. Again, 1/2 base times height. So 1/2, the base is how long now? 5 seconds. From 4 seconds to 9 seconds is 5. My height, 10. Suggesting forward motion, 25 meters. We all good here? Okay. What is the total displacement of the car? Say it again. The total displacement of the car is the absolute change in position. So the car went backwards 16, forwards 25, which means my absolute change in position was how many? 9 meters. So delta x, displacement from t equals 0 to t equals 9 is 9 meters in the positive direction. Any question about, this is nothing new yet, right? All the same stuff we've been talking about. Trying to stay nice and simple because I want to go a bridge further than this. I was unable to in fifth period due to rushing, so I don't want to rush. I want to ask some questions about this before I go on and before I rush. But before I ask too many questions, I would like to remind you that yesterday we had translated this relationship into terms that are more aligned with what we are studying. So on the vertical axis is not y, it's the velocity. The horizontal axis is not x, it is the time. We designated a symbol to use for the starting velocity. Do you remember what it was? V0 or V0 with a bar over it to indicate that it's a vector. Just like a bar should have been over this V to indicate it's a vector. We replaced the slope with a new term that I defined yesterday. What's the term? Say again? Acceleration. We use a lowercase a, which is the rate of change of velocity. I gave two further sentences after that. And this was a problem in fifth period. This problem was theirs, not mine. Negative accelerations make the velocity more negative. Positive accelerations make the velocity more positive. Do you remember those statements from yesterday? Good. I hope you do. I want to stop for a minute. So again, this is a trapezoid. It's not the trapezoid you're thinking of, but it still obeys the rules of a trapezoid. By folding it, we created part of the area in the negative side and part of the area in the positive side. And unfortunately, it really doesn't tell us much about what's happening in the middle. We would need more information if we wanted to know like when it stopped and stuff. But if all I wanted was the overview, which is all I needed, the total displacement of the object, I can still use my equation for a trapezoid, fit it out with what our actual variables mean to determine the total displacement over the interval. Now, to be honest, I don't really like this relationship very much. It counts on knowing something in the future, right? This assumes you know what the final velocity would be for the interval. So this can't make predictions. It can only tell you the displacement of the object if you know the future velocity of the object. I bring that up because this relationship tells me something about a future event if I know the initial conditions. Right? This is the initial condition, the acceleration experienced by the object. This is how fast the object is going initially at the start of the interval. If I just plug in a time in the future, I can tell you how fast it's going in the future. Do you see the difference? On your pretest, you were asked to do something for me. And one of the things you were asked to do was to take two relationships and eliminate a variable between them. Do you remember that? These were the two relationships on purpose. And I want you to eliminate a variable between them. I would like you to eliminate the final velocity. Can you do so? For those of you who can't, it's substitution. I want you to do substitution. And then I would like you to collect like terms and express it as simply as possible. And since I know I'm short on time, I must ask for you politely to hurry. I'm going to hustle you. Do you see this okay, what I've done? I did substitution. Collect like terms. Is that okay? All good? Distribute 1/2 t. All good? Is this what you get? That's what I get. Are we all good there? I want to point something out. Delta x stands for change in position, correct? Final position minus initial position. solve this for future position. We all good there? Do you notice everything on the right is an initial condition except for time? Acceleration, initial velocity, initial position. Tells me a future location based on knowing the initial positions, the initial conditions. This is a better equation than what we've seen before. It tells future events if you know the initial conditions. Also, what kind of function is it? It's quadratic.